Metamorphic processes. Here we go. While you were at Antelope Island admiring the wavy rocks, your guide passed out chocolate chip cookies. I like that guide. As you ate, you thought about how cookies are made. You mix the dough, you shape it into balls, and then you bake them. Which type of rock does this remind you of? Hmm. Cookies are a lot like metamorphic rocks. The ingredients in the cookie dough are like the different minerals in rocks. You squeeze and roll the dough into balls. Too much pressure causes the dough balls to form. You cook the dough by placing it in a hot oven. Heat causes the ingredients to change in appearance. And I want to go back a little bit. Too much pressure causes the dough balls to deform, not form. Metamorphic rocks can be grouped into two categories based on how they form. Some metamorphic rocks form when rock over a wide area is deformed by heat and pressure. Wide area. Other metamorphic rocks form when minerals recrystallize or form a new crystal structure because of the heat from the nearby magma. Let's look at deformation first. When two tectonic plates push against each other, enormous pressure is placed on the rock. Over time, tectonic forces and heat can cause the solid rock to deform. As the rock deforms, its crystals change shape, often becoming longer and thinner. They also line up parallel to each other in bands. Pressure can bend the bands. As figure 5a, this picture here, shows, deformation can cause existing rocks to change into metamorphic rocks such as schist, and gneiss. Recrystallization. I'm going to slide our picture down here. Here we go. Recrystallization. Recall that conduction is the transfer of here we go. Recall that conduction is the transfer of energy from a warmer object to a cooler object when the two objects are touching each other. And remember, energy always goes to more to less. You don't suck energy out of something that's less than you. When magma intrudes into existing rock, heat is transferred from the magma to the rock. Together with high pressure, this causes the minerals in the rock to recrystallize. This means that the atoms of the existing crystals get rearranged to form differently shaped crystals. This is similar to what happens to cookie dough on a hot baking sheet. As the baking sheet heats up, energy is transferred from the sheet to the dough. As the dough becomes warmer, its ingredients change form. Figure 5b shows two examples of how recrystallization changes existing rock into metamorphic rock. So you notice how this magma is super hot and it's heating this rock around it. Notice the bands. The sedimentary rock quartz sandstone, let's do that again. The sedimentary rock quartz sandstone forms the metamorphic rock quartzite. This happens as the quartz crystals in the sandstone form new, larger quartz crystals. Likewise, the sedimentary rock limestone forms the metamorphic rock marble. This happens when the calcite crystals in the limestone are restructured to form new, larger calcite crystals. The amount of recrystallization depends on the distance of the rock from the magma. Well, that makes sense. The closer you are, the hotter it's going to be. The farther you are away, the colder it's going to be. Rock closest to the magma undergoes more change than rock farther away from the magma. This is because the rock closest to the magma is heated up more than the rock that's farther away. Now let's think about recycling these types of rocks. This is lesson 6, or section 6, I should say. And here's the diagram of what we call the rock cycle. And if you notice, it doesn't matter where you start, you can end up anywhere you want. You can start here and you'll end up here. But if you start here, you can end up back to here. Or if you start here, you could actually circle back around on here. I mean, it's a cycle, like a bicycle. Recycling the three types of rock. Recall the photo of Rock Castle at the beginning of this lesson. You may have guessed that the rock is slowly breaking down into sand. What do you think will happen to the sand? At some point, the sand will be recycled into another rock formation. But how? How many ways can rocks be recycled? Scientists have developed a model called the rock cycle. Clever name. As figure 6, that's this figure right here, suggests or shows, the rock cycle is a continuous set of processes by which any type of rock can change into any other type of rock. In fact, it can even change back into itself. It is a model that illustrates how the flow of energy drives the cycling of rock material in the geosphere. No energy, rock doesn't change. Not a whole lot of rock is changing on the moon. Check that. No rock is changing on the moon. There's no energy on the moon. The rock cycle is driven by energy from the sun, which causes weathering and erosion by wind and water. Yeah, so the moon gets sunlight, but it doesn't have an atmosphere, so you don't get the blowing of wind, you don't get water. There's no magma inside the moon, so it just sits. It is also driven by energy from gravity, tectonic forces, and heat in the Earth's interior. Good session. Thank you.